This is Sendal. Today we are going to see about probabilistic model. Why this topic is important, we will check in next slides. So in machine learning algorithm, today we rely heavily on probabilistic models. So we are going to check about the probabilistic models, which take into considerations the uncertainty. So during the uncertainty, this model is very important, inherited in real world problems, inherited in real world data. So these models make a predictions based on the probability distributions rather than the absolute values. So it will check only the probability distributions rather than the absolute values, allowing for a more accurate understanding of complex systems. Once the common approach is Bayesian inference, where the prior knowledge is combined with observe that to make a predictions. So we had to make a predictions with the help of bias inference. The another approach is maximum likelihhood estimations, which seeks to find a model that best fits observations model. So this is the purpose of this topic. So we are going to predict that model with the help of this probabilistic distributive work. Then what is probabilistic model? So probabilistic models are an essential component of machine learning which aims to learn the patterns from the data and make the predictions on the new unseen data. So it will be predict the unseen data. They are statistical models that capture the inherent uncertainty in data and incorporate in the predictions of data. Machine learning models that directly models that probabilities of a class label given a input futures set. For example, this is an x and y data. So based upon this, it will be classified or it will be predicted. We are having two types of models. One is an generative models and discriminative models. So as you know that today we know about the generative AI. So based upon this generative models, we are using that generative AI because we had to generate the text by own. So we are using the generative models. So we will be using some techniques like an discriminative models, which is used for the next purpose, right? So then, what is generative model? So generative models aims to model the joint distributions of the input and output variables, that is x and y data. So here the input and output variables. These models generate the new data based upon the probability distributions of the original data. Uh, Generative models are the powerful because they can generate the new data that reassemble the training data. They can be used for tasks such as images and speech synthesis, language translation, and text generation. So we will be using the generative model like we can use for generate the images, speech synthesis, language translation, and text generations. So we can use the generative model like this. So this is a mathematical models. So like we can give an expressions a function of x is tends to y. We can make it like this: probabilities of p of x y by x. Assume some functional form of the probability such as p of y comma p of xy. Maybe this equations have you seen in the bias, which helps of training data. We estimate the parameters of the p of x bar y comma p of y. We use the bias theorems to calculate the posterior probabilities, that is p of y bar x. So this is the mathematical of the generative models, which is like like we will be using some concept of bias theorem, and we will be using some the concept of the probabilities theory part. Next, what is meant by distributive models? The distributive models aims to model the conditions distributions. So here we are going to for the conditional distributions, but in generative model we will be using the joint distribution models. So here we will be using of output variables given in the text input variables. They learn a decision boundary that separate the different classes of the output variables. The discriminative models are useful when the focus is on the making accurate predictions. So it will be focusing only on the accurate predictions rather than generating a new data. So it will not generate the new data. It will be used for the accurate predictions. They can be used for the tasks such as image recognition. So we will be using like an image recognition, speech recognition, and sentimental analysis. So we will be using for the generative models. So what is the mathematical of generative models? So here also we will be using some probabilities The training discriminant classifier or discriminant analysis involve estimating a function f of x comma x tends to y or probability of p bar x. Assume some functional form of the probability such as p of p bar x y bar x, which helps the training data we can estimate of y bar x. So we'll be using of probabilities and then estimate parameters for calculating the discriminative models. So what is probability discriminative models? So these are the equations to calculate the accuracy of predictions. We have the two classes problems, the posterior probabilities of the class C1. So here we are using the posterior probabilities of C1. So we can return in the form of logistic sigmoid acting on the linear function of x. So this is a weight and it is a transpose. So you can calculate this values like this. For the multiple classes cases, so here we will be using the two classes classifications. We are going to use the multiple classes, the posterior probabilities of the class ck. So if you're having multiples, it will be considered ck is given in the form of softmax. So here we will be using a sigmoid, and here we will be using the softmax transformations in the linear regressions, linear function of x. So this is the equations to calculate the multiple classes cases for the probabilities, posterior probabilities. Next, we are going to see about the difference between the generative discriminative models. So, what is the features? What it learn? It learn the joint probabilities. Here, it will be learn the conditional probabilities. What is the approaches? The full data distributions. Here, it learns the decision boundaries. Then, what is the example of this? We can see the Naïve bias, Gaussian mixture models, and GANs. So these are the recent we are using this part, right? For the generative models, we will be using the logistic regressions, SVM, and neural networks in this part. Use cases, data generations, unsupervised learnings. Here we will be using the classifications, supervised learnings. We are using the distributive models. What is the advantages in generative model? It works for only the small data sets. We can generate only the small data sets. That is a part. Here we will be using for the more accurate for complex data. We are using in the discriminatory models. What is the importance of the probabilistic models? The probabilistic models play a crucial role in the field of machine learning, providing a framework for understanding the underlying the patterns and complexity in the massive datasets. Probabilistic models provide a natural way to reason about the likelihood of the different outcomes. So there is an important point of probabilistic models, and it can be helpful to understand the laying of structure of data. Probabilistic models helps to enable the researchers, practitioners to make informed decisions when faced the uncertainty. The probabilistic models allow to the perform the Bayesian inference, which is a powerful method that updated ourselves to our beliefs about a hypothesis based on the new datasets. So these are the importance of probabilistic models. What is the advantages of probabilistic models? So probabilistic models are increasing popular method in many fields, including artificial intelligence, finance, and healthcare. The main advantages of this model is ability to take into an account of uncertainty, and variability of in data. These allow more accurate predictions and make decisions, particularly in complex and unpredictable situations. Probabilistic models can also provide high insights and into and how different factors influence outcomes and can be identify the patterns of relations between the data. This is the probabilities advantages of probabilistic model. Here we are going for to see the disadvantages of probabilistic models. This one of the disadvantages is overfitting, where the model is too specified in the training datasets and does not perform the new datasets, or not all the datasets fits into a probability framework, which can limit the usefulness of this model in certain applications. The another challenges is probabilistic models can be computationally intensive, require significant resources to develop the implements. So these are the disadvantages of probabilistic models. So where we are seeing a real world, generative models are used in the imagine learnings to differentiate the cat and dogs by understanding the possible of for futures of both. So discriminative models, here we are using the imagine models like an best to distinguish features like ears, shape, tail, length, bark, and meow to separate this. So this is a difference we are using in the real world problems. So what are the types of probabilities distributive problems? We have three types of problems like in probabilistic distributions. Here we are going for to see about the logistic regressions. It is otherwise called as binary classifications used for spam detections and fraud detections and disease predictions. So this is a mathematical expressions to calculate the logistic regressions. So what is x here and what is w and y? So x is the input features and w b are model parameters. Sigmoid functions convert the output into an you will triply convert into an probabilities of zeros and ones. Here, if you this is an example to classify the whether the email is a spam or not spam. So if the value is greater than 0, then it is considered as spam. It is less than 0, it is not a spam. So visually, the imaging plot of we can use the 2D plans where the logistic regressions draw the decision boundaries between the. So this is the purpose of logistic regressions. Next, we are going to see about the support vector machines. Here we will be seeing about that text classifications, image recognition, and medical medicine. So what is the concept of SVM? It's find the optimal and boundaries. For example, we have the data. So we have the data like an red, yellow. We have the yellows, right? Okay, we have the data like yellow colors. Maybe yellow is not visible. Okay, we have some data like in yellow colors, and we can data like we can have the data like uh, blue colors. Okay, we have the data slice. So I need to find the hyperplane which fit that to classify the data. So here we can use this to separate the data two classes. So maximize the imaginary rights within the support vectors. So this is the formulas to calculate like the hyperplane. So if the f of x is greater than 0, it is classified class 1. If it is less than 0, it is class 2. Here is an x is an input features. WP is an model parameters that otherwise we are calling as weight and bias. Sigmoid functions converts the output to the probabilities of zeros and ones. The key features works well in the high dimensional space, good for the NLP and image recognitions, can be a kernel trick to handle the linear, non-linear separable data. Example we can use for the emails support vector separate the spam and not spam by maximing the marginal between the two classes. So SVM is defined as then it is support vector machines. Here we are going to see about the hyperplanes whereas in the logistic regressions classifier defines only overall the points. Hence, the SVM enjoy the natural speed, so it will be more speeder than the logistic regressions. Okay, so this is a point we have to differentiate that green color and blue color. So what we have mentioned earlier, right? So in conditional random field, so this is the third type of probability discriminative. So here we will be using the natural language processing named entity recognitions. It is called as NER. The concept is unlike the logistic regressions, CRF models the relations between the multiple output variables commonly used to separate the sequence prediction tasks like speak recognitions, POS tagging, and text segmentations. So if you want to label words instead of persons, organizations, so we'll be using the CRF for the condition for considering the dependency between the words. For example, if we have the New York should be treated as one entity, right? So this is New York, so it is should be treated as one entity. So what is the real world of discriminative models? We are using in the spam email classifications. So we are using the model of logistic regressions and SVM. So here will be the extract the features from the emails. So word frequency, sender, and subjects. Use the logistic regressions to classify the spam or not. So next we are going to see about the face recognitions. So like Facebook, Apple Face ID. Here we will be using the neural networks and SVM. So we are extract the faces features like eye distance, nose face, etc. So will be the SVMs classify the whether the faces matches the data or not. So next we are going to see about the credit card fraud detections. We are using the logistic regressions. Use the transaction data histories. So then we will be identify the fraud detections are safe. So if the classified transaction is 1, then it is in fraud. If classified transaction is 0, then it is in safe. So medical diagnosis, it is used the AI healthcare. We will be using the support vector machines as well as neural networks. So how it is work? We will be analyzing with the help of X-rays, MR scans, and lab reports to predict the diseases probabilities, examine the COVID predictions, etc. So these are the types and the real world of application of discriminative world. And thank you for this. Thank you for listening. Please subscribe and share to others. Thank you.